Good morning, my fine pre-algebra students. I'm glad that you're being so diligent with watching and paying attention. I'm very proud of you. We're getting ready here to take a look at simple probability. Yes, I know that it says section 9.3 and we just did section 9.1. What I'm doing for this last little bit is I'm just getting a little bit of little bits of the concepts from various different sections. So we're skipping just a little bit so that you can be exposed to certain things which are good for you to be exposed to. So this is kind of a fun topic. It's called simple probability. So it's basically talking about how likely something is to happen. And when you've played games where you're spinning a spinner or rolling a dice or something like that, you are thinking in terms of probability already, and you already are kind of probably in your head calculating how likely it is for something to happen. So for example, one of the things that you can do is that you can flip a coin. Okay, flipping a coin is something a lot of people do just for fun. It is actually in the Bible, they even mention things like drawing lots and things like that to determine outcomes. So probability does appear even in things like that. So we can just take this for what it is. So if there's nothing that will influence the coin flipping or the rolling of a die or the spinning of a spinner, really there is a likelihood, a certain likelihood that certain outcomes will happen. So we take the number of ways a certain outcome can happen divided by the total possible outcomes. So when you flip a coin, the total possible outcomes is 2. Okay? And one of those is heads. So the probability of getting heads when you flip a coin will be 1 to 2. So I found this. Even if you don't have a coin, you can find a coin flipper, and the likelihood of each time I flip the coin being a heads is 1 to 2. And you can go ahead and flip and flip and flip and find out how many. I know that some of you have been half paying attention and some have not, and you found out that it didn't quite work out the way it did. I just flipped it 6 times, and I believe that if I was paying attention, 2 of those were actually heads and the rest were tails. So wait a minute, but that's 2 out of 6 flips. That's only 1/3. That's not 1/2. Well, here's the thing, is probability is how likely it is to happen. It's not a guarantee that it will happen. That's why gambling is such a bad idea. Each coin flip has a likelihood of being heads or tails, and it is a 1 to 2 likelihood, a 1 to 2 possibility. So every time I flip it, it might be heads or it might be tails. There's another heads. Every time I flip it, this one might be heads, might be tails. It's got a 1 in 2 chance of being heads or tails. Next one, it has a 1 in 2 chance. Might be heads, might be tails. Now the fact that the last 3 are heads does not make it any more or less likely that on this single flip it'll be heads or tails. Okay? Now if you were looking at the likelihood of all 4 of those flips being heads or tails, then that brings in a few more things, but each flip has a likelihood of 1 to 2, might be heads, might be tails. Okay, so back to this, and I'm going to put a link to this this random generator right on there so you can do that yourself and have a little fun with it, and that's fine. But I do have to give credit. Obviously I didn't come up with that flipper, but I had to have some way of showing you within this video. But the link will be posted with it. I don't want to take credit for it or make anybody think that I generated that. I'm using this tool that is publicly available. Okay, so for a 6-sided cube, in other words, if you have a die and you roll it, we know that the numbers 1 to 6 with the dots are on the sides of the die, and you roll that die, and the number you'll get will be 1, 2, 3, 4, 5, or 6. So the probability of getting a 2, okay, how many 2s are there on the dice? There's just one of them. So that's one possible outcome, but there are 6 different sides. So the probability of getting a 2 when you roll a die is going to be 1 to 6. So 1 out of 6 times, you're thinking that you will probably get a 2. So let's test this out. I'm going to roll a die 6 times, and we're going to say that probably one of those 6, 1 out of 6, will end up being a 2. There's one. But each time I roll it, my probability is 1 out of 6. Now in this case, it came out 1 out of the 6 was a 2. Okay, however, it doesn't guarantee that. I'll just roll them real quick again. I'll roll 1. I'm looking for the, okay. So each time I roll, the probability is that I might get a 2, and that probability is 1 out of 6. Well, that time it didn't happen at all. Doesn't mean my probability statement is wrong. There's 6 possible outcomes for each roll. So I can roll them all again. There, okay, nope. Rolling all those dice. Okay, and so the probability would be 1 out of 6 for each of those rolls, and you can roll these a lot and still not getting a 2. These are really going against the probability. It's not a guarantee, but 1 out of 6 rolls is most likely going to be a 2 if it's truly randomly generated. This is taking forever to get a 2. Wow, have you ever played a game where it took forever for you to get the one that you're really looking for? Well, eventually I'm going to get a 2. Each time I roll the dice, my probability is 1 to 6. Okay, I wasn't expecting this to take so long because the probability is 1 to 6 every time I roll that die. There it is. So my probability of rolling each one of those rolls was 1 to 6. If I roll it again, the probability of getting a 2 is still 1 to 6. Okay, oh, and there I got another one. Okay, the probability was not more or less likely for this one. I roll it again, the probability is 1 out of 6 that I'm going to get a 2. Okay, and sometimes you get a string of them. But the probability for each roll is 1 out of 6. Okay, so here's another thing to consider though. Okay, because we have, what about the probability that I get an even number if I roll those die? Well, that's different because there are 3 even numbers on a die, 2, 4, and 6. But there's still 6 possible outcomes. So reduce your fraction, and the probability is 1 out of 2. 1 out of 2 times we are probably going to get an even number. Okay, probably. Doesn't mean it will definitely happen, but the likelihood of it happening is 1 out of 2 every single time that you roll. Okay, so we have this. This is, again, simple probability is the likelihood that it's going to happen. And the more and more times that you were to do a sample roll, okay, the closer to the probable value that it would come. Okay, it doesn't mean that each individual roll is more likely, like I ended up with that whole string of 2s. Each individual one was not more likely, but as a group, okay, the ratio, the probability of having a 2 was 1 in 6. The probability of having an even number is 1 out of 2. Okay, so I can go back and I can roll these die a whole bunch of times. I'm going to clear them all out. Let me clear them out. Get rid of, get rid of, get rid of, get rid of, get rid of. Bye, 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 bye. And we want to see if it approaches 1 out of 2 as I roll the dice and roll the dice and roll the dice and roll the dice. Okay, so I roll 1. Okay, is it even? No. Is it even? Yes. Is it even? No. Is it even? No. Is it even? Yes. No. I'm just going to roll them a whole bunch more times. Remember, we're looking for evens. Okay, forget about that total that's running down the side. That's a whole different thing, but I can get a whole bunch of dice rolls here. And so what actually happened, this is not a probability, this is what actually happened for our random rolls, should come out to be close to 1 out of 2. So we have, let's do another one, make it an even. Oh, wow, okay, never mind. We'll do another one there. So I have, how many do I have? 1, 2, 3, 4, 5, 6. Let's do one more. 6 times 3, I have 18 rolls, and we want to find out how many of them were evens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of the 18. That's not exactly a half, but it's close, because remember, the probability is 1 to 2 that you're going to get an even for each individual roll. So as we roll it more and more times, okay, the probability and the actual ratio usually gets closer and closer. In this case, it's making, but each time the probability of rolling an even is going to be 1 to 2. All right, so, and if you did the whole thing, you would get different numbers because it's a random number generator. And once again, probability gives us a number that tells us a likelihood, but when you actually roll them, you come out with something different. That's the whole reason why analysts in different sporting events like the Super Bowl or just any, or the World Cup or any of those sporting events or the NBA finals, they will come up with all these probabilities of what's going to happen, but you play the game, because playing the game is actually what ends up saying what the real outcome is, but you can look at the likelihood that a certain outcome will happen. It would be 1 out of every 2 chances we would get an even on that. So I want to go back to our example that we had about the fish. Okay, we had a fish tank. There's 5 red fish, 2 blue fish, and 8 orange fish, if you remember from the last lesson. We want to look at the probability that if you took a net and you were trying to clean out your fish tank and you've got all the fish in there, the probability that you'll pull out a blue fish. Well, we need to have the number of blue fish, that would be the amount of positive outcomes. The number of blue fish is 2, but that's out of the total number of fish that are in the tank. 8 and 2 is 10, plus 5 is 15, so the probability of getting a blue fish would be 2 out of 15. The probability of getting a red fish, if they're all in the tank, is 5 out of 15. So in other words, we can reduce that, and you could say 1 out of 3. That's our probability of getting a red fish. The probability of getting a red or orange fish, there are still 15 fish, but there's 5 reds and 8 oranges. So the probability of getting either red or orange would be 13 out of 15. So 13 out of 15 times, if you just reached in there, you would end up getting a red or an orange fish. So you can have combinations of things happening. Now these that I've talked about so far are just one shot. You roll the dice once, your probability for each individual roll, the probability for each individual roll would be what we discussed. Okay, the probability for each individual swipe in the fish tank, if there were all 15 fishes in there, would come out to be these probabilities. Okay, But when you have more happening, so for example, there are some games where you roll 2 dice, okay? And in those games, sometimes if you get doubles, you get extra moves or something like that. And so there are probabilities that deal with the likelihood of 2 things happening. And that's different than the probability of just each individual roll. Okay, it's the probability of you roll both and something that's going to happen. So what we can do to find the number of total outcomes, of possible outcomes, if you roll 2 die, okay, you could get a 1 and a 1. You could get a 1 and a 2. Okay, the first die will either be a 1, 2, 3, 4, 5, or 6. The second dice will be a 1, 2, 3, 4, 5, or 6. So if the first die comes out with a 1, the second one might be a 1, 2, 3, 4, 5, or 6. If the second die if the first die comes out as a 2, the second one could be a 1, 2, 3, 4, 5, 6. If the first die comes out as a 3, the second one could come out as a 1, 2, 3, 4, 5, or 6. If the first one comes out as a 4, the second one would be a 1 to 6. So on and on and on. If the first roll was a 6, the second one might be 1, 2, 3, 4, 5, or 6. So the probability that you get doubles, okay, so is based on the number of doubles, in other words, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6, out of all of the outcomes for rolling 2 die. So all of the outcomes for rolling 2 die is 36. There are 36 outcomes. And out of those 36 outcomes, there are 6 doubles. That means when you roll 2 die, the probability of getting a double is 1 out of 6. So in other words, the probability of you getting a double, it doesn't matter what double, but the probability of getting doubles, okay, is 1 out of 6. And a lot of times we think about it as not being quite that, but it is. Okay, let's look at this one. Let's look at another one. The probability that both of the numbers are less than 4. Okay, we have to think a little bit more for that. So do it systematically though. Okay, I don't mean both of them added together are less than 4, but I mean both of the numbers are less than 4. So here, okay, first one's 1, second one's 1, so that's 1, 2, 3. This one doesn't work because both of them are not, so 3, 4, 5, 6, because both 2 and 3 are less than 4. 3 is less than 4 and so is 1, so 7, 8, 9. But then we get here, we can't do any more here because 4 is not less than 4. Okay, so we're done with that. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 36 outcomes. 9 out of the 36 outcomes, and when we reduce that, we get 1 out of 4. Okay, that gives you the probability that both of them are less than 4 is 1 out of 4. Okay, now this is simple probability. We're not looking at necessarily the order of the numbers. We're looking at the possible outcomes, and we're looking at which ones, by counting, come out to meet the criteria. Okay, so let's look at another one. The probability that that both include a 1. Okay, so the probability, I wrote that wrong. I don't mean probability that both are 1. Well, let's leave it this way. Both of them are 1. Both are 1. So the probability that both are 1 is only here. Okay, 1 out of 36. Okay, so what I really wanted to do, and let's do another one, the probability that one of them is a 1. The probability that one of them is a 1. So let's check here. We want to find all the ones that have 1s in them. So I have, this one has a 1. This one has a 1. So 1, 2, 3, 4, 5, 6. But so does this one. 7, 8, 9, 10, 11. 11 out of 36 have a 1 in the pair somewhere. The probability that both are 1 is 1 out of 36. That's very rare. The probability that you get doubles is 1 out of 6. The probability that both numbers in the pair are less than 4 is 1 out of 4. So you can use this chart. This chart is also in your book, but you can use this chart to be able to find the probabilities when you roll 2 die that any of these particular outcomes happen. And that is all for today. And so tomorrow you're going to have a work day on assignment 85, and you're going to make sure to turn that in on Friday, tomorrow. And so that you are going to have Monday off because it's Memorial Day, obviously. And then you're going to do some practice on Tuesday. And Wednesday next week is not a rest day. Okay, Wednesday next week is not a rest day. You have a quiz on Wednesday on chapter 9, sections 1 through 3. Okay, then we'll do just a little bit more. I want to stretch you. Don't want to break you. We'll do some reviewing for a last test. Okay, if the word final exam scares you, don't worry about it. We're going to do a last test, so we'll be working on some reviewing also with that. But for right now, you're focusing on this, about the probability or the likelihood that something will happen. Okay. God bless you and have a great day.